Good morning, everybody. My name is Kasper Knol. I am a data scientist at Ford Motor Company, and I'm based in Cologne, Germany. And today we're going to talk about quite a lot of things. First, I'm just going to give you a glimpse of the day-to-day work that I do, and a little bit about the data that I work with. And then to the end, we come to some tips and maybe useful things to look at the data and give you some advice or inspiration to work on your own projects. So what we see here is a vision of the city of tomorrow. You already see quite a lot of connected vehicles or electric vehicles, not as many scooters that I saw here in Stockholm this few days. I was really surprised. You see them everywhere. In Amsterdam, you have to take care of all the bikes and you have to really look out, but here it's definitely the street scooters that are an hazard on the track. So an industry where quite a lot of changes are. We have a long tradition going from pure manufacturing and building stuff to coming to a new situation where new technologies emerge. Vehicles are connected. You can use an app to maybe call a vehicle to come to you, ride sharing, and all these new things that are coming. Electrification, there should be an electric network where you can plug in your cars, moving from A to B, all elements that are increasingly important for Ford and that we need to look at. So my role within the company is that I'm a data scientist in the Data Insight and Analytics organization. It's a global organization all around the world. As mentioned, I'm then located in Cologne, and we have a European team that looks for most of the European data. We have quite a lot of different teams in all kind of subjects like manufacturing, marketing, sales, all these kind of things. But I'm working in the smart mobility and analytics, so a little bit new things for Ford. We've been building stuff for quite a long time, but now we have opportunities to connect to vehicles and learn movement pattern and usage behavior, not only from our tests that we do on our test tracks, but also in the field and really see actual figures and usage of customers. So what kind of things do I do? I look at vehicle information, of course. So we look to how can we improve the vehicle. So can we detect early problems in the development stage? Normally you would always have tests and on test tracks and you test things, but also in the first couple of months when a new model is launched and it has a device on board that sends information back, it is really useful for us to immediately see, okay, what kind of problems are maybe still there and how can we fix it, and then not be reactive, wait till somebody goes to the garage and we need to fix something, but be proactive. So totally different shift that is becoming more and more, and I think it's across industries where you see much more communication with the customer and much more interactions. Then we come to interactions. So customer, do we need to change something internally, or do we need to inform a customer that it needs to come back to the garage and have an additional look at the vehicle? Is it necessary? Of course, safety concerns are always necessary. Maybe some people view with your vehicle that you have also got a letter or a call that something was wrong with your vehicle. You needed to come back and they do a different check. That's an unfortunate, but better that you get informed than if it's too late. And it can also be for smaller things. Maybe there's something wrong with a specific component. It's not really of safety issues or some kind of things, but it will, if you invest something now or if you come by and we fix it for free, it will save you lots of expenses in the future. So we're trying to find those things. And new things that are there is then the third thing is creating the new solutions. So we have much more data, so we also have the opportunity to look at usage patterns in a city. So how do vehicles behave in a city and how are they used? Is the usage patterns, is it good enough for that the whole vehicle could be electric with the distance people traveled, and what's the performance and how is it really used? it's different than on a test track, so you really can see. With all the information that we have, can we identify good locations where we can put charging infrastructures for the vehicles? What's handy for not only what the government wants or the city, because they have a piece of land somewhere where they can put something, but is it close by to actual spots where people go, and is it convenient to go there? So quite a lot of new things that you can do. Tools that I used. I'm quite open source minded in that sense. You see here a little bit the systems. We have our Hadoop platform where we store and gather all the data. Of course, there are lots of things we need to do for that, because as we saw, we're quite an old company with lots of legacy systems, as probably some of you also work in such a company, so it's not always easy getting the data there. For today, that's not really the topic, or it takes too much time. So we bundle our data and then have opportunities to look at it. As all mentioned, everybody has nowadays with the sensors quite a lot of data, so we need some big data tools to really perform and analyze all the things that you want. So I do quite a lot of work with Spark, and then mostly code in Python or Scala for solutions. So that's getting the machine learning stuff there, then getting it to the vehicle or doing in-vehicle calculations or in the cloud and informing. There we have to find other solutions. My day-to-day thing is I open the laptop and do stuff in the command line, or have specific notebooks where I do my prototyping and testing in these kind of environments. I really like them because you can immediately visualize things. We come to those things later on. Machine learning, I think the standard things that most people use, all packages that you use, maybe you use totally different systems, they all have the basic same functions or math solutions in them. So it's a little bit irrelevant, and then probably in a couple of years it will change again. New names, some same systems, some new systems. So let's have a look for what changed for Ford with the connected vehicle data. So we always had vehicles, so there's nothing new. A vehicle has the internal communications. There are quite a lot of components talking to each other and then communicating if something works or doesn't work. Maybe a few of you, when you stop for a traffic light and then you want to do your start option, so the motor really shuts down, and then when you hit or release the brake, it starts again, and it's more fuel efficient and environment friendly. Sometimes it doesn't work. That's because before that feature is in place, specific components needs to talk with each other. So your battery, your starter battery needs to be sufficient, maybe your steering wheel angle or the gradient of the street where you're standing. If it's really steep, then probably it will not function. So quite a lot of things already communicating and quite a lot of data there. So always the case. Here you have some more examples of all the things that are there. I think we heard quite a lot of things about temperature, fuel efficiency already, and speeds and those kind of things in our conference. But there are, of course, also other things. We'll come back to that later with more text features. So diagnostic trouble codes, or if your warning light is a yes, no, and a specific thing, and how you take an average of a yes, no, or a code. I don't know. So there are different solutions you need to think of. But most things are already in the vehicles. Of course, you always like some additional ones for your models, because then it makes 100% fits with your data. But now connectivity. So more and more vehicles in Europe having the opportunity that they are connected to a network, or they have a modem and they send information, and customers can use new features, and there's an opportunity to talk with them. I think the last 2 days there was already a lot of information about sensors and getting back, and that's all physical at a location. But now these things are sold to a customer, and he's driving everywhere, and probably we have a little bit more frequency of number of vehicles than we have machines at a specific plant. Maybe less data in with all the sensors, but so finding a good combination. So this data can be sent back to Ford. Really nice. For me, data scientist, I like to have all the data. Really awesome. But what exactly is sent back? There are 3 things that you really need to consider. I think the signal availability that already is in the vehicle. Of course, the device that records. I think we already talked a little bit about recording devices and what can it send. Maybe you have to do some compilations on in my case, the vehicle or these kind of things. What I haven't heard that much the last 2 days is the regulations with the new European regulations. That for us, that's a big deal because what we heard the last couple of days was mostly business to business or a machine standing somewhere that is already owned by me. So not really a concern, but now we created a vehicle. It can drive everywhere. We sold it. So the data is from whom? Is it from the customer or is it from us? Is it our end? And how should we work with it? And if I have specific information, is it privacy or the privacy things with it or all these kind of things? We at Ford, you have the opportunity to sign in for it, and you can switch off specific signals that you don't want us to track. Could be GPS locations or other signals that you don't want to share. So try to be really transparent in the sense of what can we do, what can't we do. And now, if for Europe, for these capabilities is mostly a small number of vehicles like the Focus and those kind of vehicles getting more and more opportunities for sending this information. In the US, it's already much bigger, but it's coming here. You've probably seen it from Tesla or other companies where there's more connectivity and new features coming out. What I want to talk about is an example about battery problems. So it's the starter battery in a vehicle. So does it start? Yes, no, and can we find something? So this is roughly the concept that I want to create. Future battery problems, yes, no. Binary classifications, is something going wrong? Yes, no, in the future. That's probably going to be some kind of a function. You see here, a function, whatever machine learning thing you want to do, you can put on it, and it's going to be continuous and categorical features. Continuous are the signals that we already talked about quite a lot. It can be vehicle speed, battery levels, all these kind of things. For categorical, think about groups, text, descriptions of machines. You have different machines. You need to have some reference in it. Specific codes you have. Sometimes you have codes. What to do with codes? It's a totally different topic. Again, similar things. Domain knowledge, pure machine learning. So put everything in, and then the solution will come here in the blue. But of course, you need quite a lot of data for it to work. And fortunately, we all work at good companies that already have quite a lot of experience in our field, so we should leverage it. I think was already touched upon before. You need to know specific information. If you have prior knowledge, that's really welcome. In our case, we have prior knowledge, but now that the transmitting device is in the vehicle, previously you could only go to the garage, put something into the vehicle and download the information and you could see it. So there was only from the vehicles that already had failures or that you suspected that something was wrong. And it was decentralized at the dealership or whatever. And now you get all the information, so also the healthy and the good information. So totally different. So there is lots of domain knowledge, but it's different data that we didn't see before. So the engineers or the other people, they have knowledge, how it should work, but the signals that actually are there, it's different. So finding a correct balance is always good. So 3 things I want to talk about for the precise example. So it's visualization, visualize your data. It's finding out what is special, giving context. So how can I be more effective? It's your machine learning learns everything what you put into it. And then most of the time it doesn't have enough data to come up with the answer you wanted or the complexity. So you have to put in more context. And then choosing your prediction period. You find a balance from what can I predict and what actions do I want to take. So you have a use case, do I want to call somebody? Do I need to repair something? Do I need to make some kind of list of things that I need to buy to install into the vehicles? All these kind of things I need to know in advance when I'm predicting something. First thing, continuous variable, state of charge, temperature could all be important for a future battery failure. Cold temperatures, warm temperatures, different behavior, all these kind of things. They're visualizing time-based. We've seen quite a lot of examples. It doesn't have to be that fancy. It's just plotting it on a line and see, everybody can see. Okay, probably there's something going on. This is also strange. If I have a specific event, a labeling thing, just put it on. Nothing special in that sense. Everybody does it, but how wide are you sharing it within your organization? If I only look at it into my screen, then I'm really confident that it works. But if a decision maker or an end user doesn't see it and doesn't really have access to that data, it will not work. So then create a dashboard or other visualization tool and just share it, even if it's just prototyping or whatever. Just make it visible that you can really engage and an expert really can go into it and say, yeah, this is good, it isn't good, I don't understand. And mostly when they say I don't understand, then you're off to a good start or a good solution where to go. Investigate all the things that are wrong about your data. Something comes out and he says, it doesn't work. Your engineer says, it's totally wrong. So investigate those things back to your data that came into your model. Maybe there's something wrong with the data, the sensor was off, or there is a new solution that nobody thought of. So really not only look at the good things, but really zoom into your bad things. So what are you doing wrong? And can you identify what was wrong? And then you get understanding, and then you can better explain it, all these things, and the acceptance of your model or your thing gets really bigger, because that's the whole process. I can make the best model, those kind of things, but if nobody uses, we heard it in the prior session, I call it's a model in a box. You have a box there, it's a model, you can put it on a shelf, it looks really nice, but nobody does something with it, but it looks awesome. It will not do anything for you. So I want to touch a little bit about things that we didn't hear that much up to now. It's about looking into codes and text things. So vehicle descriptions could be descriptions of a machine, components, those kind of things. It's interesting data for your model to learn. We have diagnostic trouble codes. That means specific code that say that something is wrong. Most of the time it's interesting because they already predefine checks of sensors you may not have or may not receive. So it's additional to your other things. So here's a little bit of an explanation what it is for us, a diagnostic trouble code. So it's standardized code. You would find them in all vehicles, all manufacturers. There are some specific sets that are always similar, and then some dialects, call it, or specifics for the person that is making the vehicle or the engineer. So it gives a level of information about something's going wrong, or there is a condition has been met. Something was achieved or something wasn't achieved. Those kind of things. So it's called a trouble code. It doesn't always mean there's really something wrong. But it's generic. The name is really precise, but in practice it's really generic. That something is wrong doesn't always mean that it's wrong for your problem. It's just set. You have no relevance to it. So what is relevant, what isn't relevant? And then coming up with how to put it in. I have thousands of different codes. But which ones do I need? Of course, with some domain knowledge, the engineer would give me maybe a list of 10 or 15. Could be interesting. Have a look. But on the other side, there's so many more that maybe also be interesting. So a technique that I used, and I borrowed from other industries, is looking at TDF, IDF, so term frequency, inverse document frequency. Widely used in text analysis when you read books and create summaries and those kind of things. So for me, a code is just like a text. And I just see it as, it has different meanings, but it's just a text thing that I can use. You can maybe also use it for websites or URLs and just give a label to it. And then I need to find what is special and what isn't special. Because for some things that occur at maybe 80% of all vehicles, or for every hour that you analyze, if you go to looking at machines, maybe every hour the codes are set 10 times. But if it goes to 1 time or to 100 times, it's a totally different shift. So what I do, as an example, I give, okay, we have a document. For me, a document is a vehicle. It could be a machine. It could be a machine per hour, those kind of things, and just create an array with all the codes that I see. These are just simple ones. So vehicle 1 has K, A, and B. And then you can read it for vehicle 2 and vehicle 3. I use these things to look, okay, how many vehicles do I have? How many machines do I have? How many operating hours do I have? And what is a normal operating hour or a normal vehicle doing? Then how many DTCs does my period of interest have? So here you would have 3 vehicles, you see, and then you have to count how many codes there are for that vehicle. And then take the log to get, if it's a low thing, low frequency, high weights, so I have to inverse it a little bit. That's the inverse in the name. So if I do it here, and quickly for an example, let's look at vehicle 1. So vehicle 1, we look at K. So there are 3 vehicles in total. K is only 1 time there. Let me see if I'm gonna point to it. So 1 time the number K. In total it was at vehicle 1 and at vehicle 3. So if a 2 there. So I get a specific score. If I do it for A, I see, okay, there was only 1 vehicle that has an A. That's my first vehicle. So it's special. And for B, it's everywhere. Everybody has it. So maybe for my problem, it is noise. Or maybe it's a precondition that needs to be set for an operation to work. Here you see then the rare events, so that gives a little bit more context. You can put everything in and maybe do, if it says something to you, 1 hot encoding of all the different codes that you have. But probably you don't have that much data to really get into the problem. You create lots of variables, but and the model will never really learn what you want to do. You're just sitting there and it learns and doesn't come to an end solution. And this is a way to speed up the process and then give some prior knowledge of what is maybe special and what isn't special, and then the model will see if it's important for your problem. Doing all these kind of things will not guarantee that it will work for you. It's just creating the opportunity that it probably will work. All available statistical programs or libraries you use have these kind of features, and then mostly it's in combination with a hashing function to make it more efficient for your problem to do it. Please have a look if you think it's interesting for you. Online there are good explanations how it works, and just for you to give some inspiration, because mostly you only think about signals, and then they may continuous variables, speed, sensors, you have everything, but most cases you also have codes of sensors you maybe don't receive information from. And how do I get value off of that? And for me it helped. Hopefully for your industry it will also help finding better solutions. Okay, define future, the last thing. What is future? Now, tomorrow, next week, in 3 weeks? Nobody knows. So it's, again, finding a good balance between the two. What does your data have, and what are your actions you're going to take? If I decide to make a really good model, 100% accuracy, but it's only 1 second before the failure happens. Doesn't bring any value, but I can say I have a 100% model. It looks really nice. It's the best model, but it will not work. So you need to find and test also as a data scientist different scenarios. So if I do it in 2 weeks, 3 weeks, 4 months, can I already see specific things? And one interesting thing that you can do, so look at what are your important features. And does a specific feature is maybe also time dependent in the future. So maybe your best feature where you get really good accuracy only works 1 week before the failure occurs or really close by. Then it's a really good feature, but if it takes you 2 weeks to come up with an action because somebody needs to make a call, somebody needs to make a letter or an invoice for material that has to be done. In other industries, they maybe need to have that material flown to the other side of the world, or those kind of things. It will take 2-3 weeks, so that really good feature for you is maybe not fitting in your concept. I think it's from top down, it makes lots of sense, but as a data scientist, you sometimes just want to see what works best and come up with the best model because you think you're also evaluated by creating good models. But being effective means creating a model that works for your organization. And it could be that I need to lose some accuracy in the model that I make, but in practice it works much better. That's why you also need then feedback loops if it's really working and what is real world advantages you get. Hope you found some things interesting and you can use it. For me, that was the end of the presentation, but I'm open to any questions or things you would like to ask or comment. Thank you.